what is the length of ML? So what we're looking at here is two congruent angles, and then they both have this perpendicular line segment that connects at the angle's bisector. I think just looking at this picture, a lot of people are going to just assume that these are congruent to each other, these line segments, and you're correct. They would be correct. Some people might second guess themselves though, but these being perpendicular and the angles being congruent, that tells us that these are congruent as well. So that means that we can do some algebra to solve for x. 2x plus 4 is equal to 4x minus 10. Draw this line usually as a reminder to keep everything balanced. We're going to eliminate the variable on the left side. Remember that only like terms can subtract from each other, so since these things have a variable, the x, they aren't affecting the constant like the 4 and the negative 10. We'll deal with those in a second. Next, I should eliminate this 10 by adding 10 on both sides. That gives us that 14 is equal to 2x. Last step would be to divide both sides by 2, which leaves me x equals 7. And they did something tricky here. They made the first option 7. A lot of people are going to be excited to be done with the algebra portion and click 7 and move on to the next problem because they're rushing. Now they'll get this wrong because it's a trap they've set. They want to know the length of ML, which is this line segment. They don't want to know the value of x, but finding the value of x was the necessary step to figuring out this length. Because now that I know that x equals 7, I have to plug it in. So 4 times 7 minus 10. I'm not going to pull out the calculator to visualize. I need to be consistent. 4 times 7 gives us 28. So now I have 28 minus 10, which will give us 18. Here's proof. So there it is. We plugged in x and we got 18. So that is the length of line segment ML, 18 units. So that's our answer, option D.